In this lesson, we solve a piston and gas example by computing the work done during two quasi-static processes. Part A is a constant pressure expansion from volume 0.04 to 0.10 cubic meters. Part B is an isothermal expansion at 300 Kelvin from the same initial state to the same final volume. First, let's build an intuitive picture. We will draw a cylinder with a movable piston on top and some small weights on the piston. At the initial state, the gas occupies a smaller volume, and after expansion the piston rises and the gas volume increases. Part A, constant pressure expansion. The pressure stays at 200 kilopascals the whole time, so the piston lifts at a steady external pressure. We will raise the piston to represent the final volume 0.10 cubic meters. On a pressure-volume diagram, constant pressure is a horizontal line. The work done by the gas equals the area under the curve from V1 to V2. For constant pressure, work done by the gas equals P times delta V. Here P is 200 kilopascals and delta V is 0.06 cubic meters. So W equals 200 kilopascals times 0.06, giving 12 kilojoules. Part B. Now remove the weights gradually so that the gas expands isothermally at 300 Kelvin. On an ideal gas, an isothermal process has P times V equal to a constant. From the initial state, P1 times V1 equals 8 kilopascal cubic meters. On the pressure-volume diagram, the isotherm is a decreasing curve, P equals K over V. The work done by the gas is the area under this curve from V1 to V2. For an isothermal ideal gas, the work done by the gas equals K times the natural log of V2 over V1, where K equals P1 times V1. Here K equals 200 kilopascals times 0.04 cubic meters, that is 8 kilopascal cubic meters. So W equals 8 kilojoules times the natural log of 2.5, which is about 7.33 kilojoules. Summary: for the constant pressure expansion, work by the gas equals 12 kilojoules. For the isothermal expansion at 300 Kelvin from the same initial state to the same final volume, work by the gas equals about 7.33 kilojoules. Notice both are positive because the gas expands, but the isothermal curve lies below the constant pressure line on this interval, so the area and the work are smaller.